Yeah. Good evening, my dear faculty members. We will start session in 2 to 3 minutes. Meanwhile, if you are having any doubts of the previous session, please let me know. So we'll wait for 2 minutes for the rest of the faculty and we will start.
Hello.
Hi, sir.
Sir, this is Uday Kumar from St. Joseph Institute of Technology.
Yeah. Hi, sir.
Are you giving internship program through online for first year EC students?
Yes, sir. Actually, this summer we are hosting summer training cum internship activity. Training cum internship. It's a 45 days duration. So out of 45 days, 4 to 5 weeks.
June 8th to June 28th we require.
Yes. It's available,
what
sir.
are the terms for that?
Sorry?
What are the terms? Is there any fees like that, or it is free of cost?
No, sir. For free of cost, every semester we are conducting 2 scholarship exams. This semester we already conducted scholarship exam. For those who cleared the scholarship exam, will get at free of cost. For the rest of the people, as it is like a training cum internship, it's a 6 weeks program basically. Out of 6 weeks, 4 to 5 weeks will be in online mode. The theory, coding, simulations, everything will be covered in online mode. 1 to 2 weeks based on the student availability, they're supposed to come to our offline centers.
Oh, okay.
So this time we are conducting 4 EC related courses, 4 EC related training cum internship. Those are industrial IoT, like whatever we are presenting, there will be advanced for the students. And the second thing is embedded systems using ARM Cortex M3 M4 controllers, basically LPC 1768 and STM32. And third one is FPGA based VLSI design. Here we are designing, we are dealing with 5 kinds of FPGA boards: D10 Lite, D10 Nano, RTX 7 Edge, and Nexus 4 DDR. There are 5 to 6 types of FPGA boards. There is a third training cum internship, and fourth one is system Verilog. And based on these 4 training cum internship activity, and we are conducting 4 different batches. One batch starts at May 1st, and second one is starts at May 10th, and third batch will be started May 25th, and fourth batch will be started at June 5th. So your students will be suitable for June 5th batch, and the locations will be like and the locations are Hyderabad, Vijayawada, and Mangalagiri. So these are the 3 different locations for summer training cum internship activity.
Okay, sir. Okay.
So we are.
Can you share details through email,
Yeah.
sir? I will share my email ID.
Yeah, sure, sir. Please drop your mail ID in the chat box.
The chat box, I will share my email ID.
So you are from which college, sir?
St. Joseph Technology.
Okay, sir. Okay. Our team will get back, sir. Okay, sir. Okay. Please drop your mail ID along with mobile number. Please drop your mail ID along with mobile number so that our team members will get back. And we will explain in detail about our summer activity at 7 p.m. Mr. Sai Shankar also joined. He is the tutor for one of the summer training and internship activities.
Okay.
So
this is my mail ID and mobile number. I will share.
Yes. We got it, sir.
Okay.
I just shared with Surya. He is completely taken care about those activities.
Because most of the students there are asking.
Yes.
We have strength around 183 in first year, 186 in second year, and 186 in third year.
Yes, sir. It will be helpful for the students.
Around 500 students will be there.
Yes.
More than 500.
Yes, sir. That will be helpful for the students. So basically, there is no one is providing live interaction session. That is the first thing, and the second thing is there is no one come forward to implement the things on hardware. So we basically come up with a live interaction session. Though we have recording sessions, if the students are unable to attend the sessions, so we will provide the recording and we will invite students for the offline sessions. Then only they will get the something related to the EC stuff. And we are focusing on long-term relation. It's not only summer training cum internship. As an individual and community, we cleared 15 nationals and international competitions. So those who are up to mark, we will help the students to clear n number of nationals and international competitions and hackathons. That's the first segment. And we will help the students to write their own UGC care or journals. So this is how we are expecting long relation those who are enrolled with our Sun Semiconductor for summer training and mentorship activity. So we will start the session, sir. So in detail, we will explain at 7:10 after the completion of this today's topic. So I would like to know if you are having any doubts, please let me know. We will start in 2 minutes.
So this is a internship duration for second year and third year.
Okay, sir. Okay. So yes, they will be fit for May 25th batch, sir. And first years can be suitable for June 5th batch, sir.
That starts from June 8th.
Yes, like 2 to 3 days. That will be interactive kind of sessions. We will provide the recording and we will take extra sessions to meet with the ongoing batch. You are from which region, sir?
Sir?
Andhra or Telangana? Andhra or Telangana, sir?
No, I am from Chennai.
Okay, fine, sir. Fine. We are ACT approved. Like this, FDP also part of AICTE. So students will get the certificate from AICTE as well. Okay. Yeah.
Okay. Thank you.
Okay. So any doubts of the yesterday session? I'm unable to, due to some other client meeting, I'm unable to join in the previous meeting. So sorry for that. Today, I would like to cover the rest of the topics. So any doubts? Okay, fine. So good evening, all. Welcome to day 6 or day 7 of our industrial IoT FDP. So we'll start our today's topic. So hope you are following our sessions. If you are having any doubts, feel free to ask us. So I shared how to install ESP, and today I will display like how to install Arduino IDE. Like we received the message from many faculty, like they are unable to download and install ESP IDF. So they are requesting us to deal with Arduino IDE, so that many of the students are doing things with Arduino IDE. So that today's session we are going to discuss about how to install Arduino IDE. So if you are having your laptops, please follow me to download how to install ESP IDF and how to download the coding. Okay, so that it will be helpful for you to implement the things in the live itself. Okay, so is my screen is visible, sir? So it's about module 4. As of now, it's in module 1, we are discussing about what is IoT and how IoT works and the basic elements of IoT. This is what the module 1. And module 2, it's all about electronic components. What are the different components and what are the applications of different electronic components. And day 3, we are discussing about the different online tools to give the electrical connections and do all of the code to see the simulation. That is what module 3. And module 4, we are going to explore different evolution kits. Basically, these are the evolution kits to evaluate whatever the things we want before going for a real-time product. So today we will discuss about exploration of different IoT boards and simulation for the IoT applications. So here we are dealing with, yeah.
When do we get like a recording session because we missed some classes?
Yes. Actually, every day recording sessions are uploading through Google Drive, I guess. Every day at the end of the day.
No, where we
No.
didn't get a link. I didn't get it.
Yeah, just give me a second. Actually,
No,
everything.
drive link already shared, sir.
Sorry?
Drive link already shared, no?
Sorry, sir, I'm unable to get it, please.
Sir, drive link already shared, no?
Yes. Drive link already shared. Everything, every PPT and every recording session, everything is included in the Google Drive. I will share. I will share again. Yeah.
Okay, that's nice.
So that every day you will get the recording sessions there. In your document, there are recording sessions. and thereafter you will get the day-to-day presentations also we kept there. Like it will be easy to you guys to teach to your respective students. That's why we are keeping our work with you guys. So I already shared the Google Drive link. There you can find the recording sessions and the PPTs for both PCB and IIoT. Okay. So as of now, we are discussing about 4 topics. First module, it's all about what is IoT. Like this is a pattern we designed to easily get into the IoT. The first topic is about what is IoT and how it works and what are the applications of it. That's the first module. And the second module we are discussing about what are the different electronic components deals with industrial IoT, like resistor, capacitor, RLC circuits, their importance. This is what we discussed in the day 2 session and module 2. And module 3, we are discussing about different online simulators to simulate the circuit, so to write the code, to see the results. So this is what the module 3 covers. And module 4, today we will discuss about exploration of IoT, different IoT evolution boards. Not IoT industry standard boards, it's a evolution, basic evolution boards for student level projects and simulations for those particular IoT applications. So hope you guys are aware about Tinkercad work which we covered in the previous session. Somehow we will share the PPT. So please go through it. And based on the many faculty requests, today we are going to discuss about how to install Arduino IDE. Many faculty are unable to follow ESP-IDF as it is new to them. So we are only discussing about Arduino IDE for this particular rest of the days, for the better understanding from the of the faculty. So today we will discuss about exploration of controller boards, controller evolution boards, and their software. And thereafter we will discuss about independent introduction to the individual microcontroller boards. Thereafter we will discuss about in-depth about Arduino IDE, Arduino software, and Arduino controller. And thereafter we will discuss about GPIO, introduction for the Arduino. And thereafter we will discuss about ESP32 and its GPIO topic, and thereafter software installation and introduction to CP2102, and thereafter basic GPIO application with ESP32 and Arduino. So these are the basic stuff for today. So here we will discuss about different we are going to explore different evolution kits available for implement the things on the in the student level. Thereafter we would like to go for in detail and software installation and basic example. So 4 topics major we are going to cover. So exploration, controlling boards, and their software IDs for IIoT development. So basically many of you guys are aware about Arduino and ESP8266 and ESP32. These are the 3 general purpose IoT evolution boards which are widely available and which are cost effective. And thing here is, if you want to develop any application on the real time, these controllers are not enough. That might be ESP8266, that might be ESP32, but these evolution boards, these controllers are fit to go through to prove our proof of concept. If you are having some concepts, like if you want to drive some motor, if you want to take some sensors data, and if you want to do some calculations, or if you want to do some process, these controller boards are much enough. Like these are okay for the prototype purpose. If the prototype was clear, then we will go for advanced controllers that like ARM Cortex M3, M4, like LPC1768, STM32. These type of controllers we are going to use. Like here is the quick question: why these controllers Arduino, ESP86, ESP32 are not suitable for the real-time applications? Any guesses or any answers? Like when we are many of the students and many of the training institutes saying Arduino, ESP86, ESP32, but why these are not suitable for real time? Yeah, please.
Because they operate on less bits,
They are having
less bit operation.
okay, correct.
Because the ARM controller works on 32 bits.
Mhm.
Because this have that in parallel pipelining on.
Exactly, ma'am. Your good name, ma'am?
Aruna.
Okay.
Aruna. Yes.
Perfect, ma'am. And let me explain. These Arduino ESP8266, ESP32 are widely available. That's the first thing. They are widely available in the market. That's why we are going to use for prototype. And they are cost effective. These boards are hardly cost around 300 to 400, not more than that. And the third factor is these boards having extensive pins. Like we no need to do connections each and every time. They are like we can connect through jumper wires. So we can easily do our prototype. Okay, that's the third factor. So because of these three reasons, we are going to use these particular evolution boards. And one more thing, to prove our functional, these are controllers also having functionalities like ADC. They are support for ADC, analog to digital converter, digital to analog converter, and pulse width modulation. It will be support for pulse width modulation, and it will be support for UART. It will be these ICs are support for I2C and SPA. The bare concepts are same. If there is a one sensor called temperature sensor, that will be work with I2C interfacing. So if you want to interface, if you want to read the data from I2C, as IoT works on 4 steps. One is sensing. Second thing is, anyone? First is sensing, and the second one is communicating, and the third one is analyzing, and fourth one is act. This is how IoT works. IoT works in 4 steps: sense, after sensing, communicating, after communicating, analyzing, and finally act. So if you want to interface some temperature sensor, if the room temperature is greater than 30 degree, you'll be supposed to turn on the fan or AC. So if the temperature sensor is having the I2C protocol, so this Arduino IDE will support for I2C. This ESP8266 also support for I2C, and this ASP32 or 866, this is also suitable for I2C. So that we can simply interface this particular sensor to this particular any one of these evolution boards. So that whenever we are writing code inside this particular evolution kit, we are able to initialize that sensor, and we are able to read the data. So that our functionality will through here. We came to like the sensor works fine, and we are able to understand the functionality of sensor, and we are able to scan the data, read the data. Thing here is, why should these controllers are not suitable for real time? The thing here is, these are having less clock frequency is low. When advanced industrial controllers are working with 100 MHz, 150 MHz, 200, 180 MHz, but these controls hardly support up to 30, 40, 80. We can get up to 150 or 180, but we need to use crystal oscillator or oscillator to improve this clock frequency. That's the first thing. These basically working in low speed, which will not suitable for the real time. And the second thing is durability. Sorry, any doubts? Yeah. Second thing is durability. When we are using this ESP32 or ESP8266 Arduino, these components are not suitable real time. They will not survive for 10 years or 15 years. They will be get damaged within a year or 2 years. So when we want to deploy if you want to deploy our product in the real time, the customer expected to stay that particular product without any damage. The main controller supposed to stay at least for 10 to 15 years. But in this case, they will be stay for 2 to 3 years. Not more than that. That's the second problem. First thing is low frequency, so that low things are doing in a slow manner. And second thing is components durability. They will not stay for 10 years or 15 years. And third thing is no pipelining concepts are here, so that the activities will take place in sequence manner, one by one, so that the time to execute all the activities will be longer when compared to the advanced controllers which are having parallel pipelining. There's a third thing. And fourth thing is number of pins. If you are taking ESP32, it's hardly having 38 pins or 40 pins. We will discuss in detail in the coming slides. I know it's hardly having 20 to 25 pins. Because of pins limitation, we are unable to produce a huge application. If the application is small enough, and if you want to execute that application, if you are expecting the life period of that particular product for 2 to 3 years, then ESP32, ESP8266 Arduino INO is sufficient or okay. If you are expecting long-term product durability for 10 years or 15 years, and if you want to do operation within a less fraction of time, that means high clock frequency. And if you want to build a big application, So if you want to build a bigger application, basically at that moment also these controllers are not suitable. That's why these evolution boards generally we are used for prototyping purpose only. Okay, so whereas if you want to see why Arduino, why ESP32, why ESP86, Arduino, it's a general purpose development board based on microcontrollers. Okay, whereas ESP8266, it's having Wi-Fi development board based on an ESP8266 module. If you are seeing the white color one, this is the ESP8266 module, whereas Arduino, we don't have option for Wi-Fi. If you want to send some data to the cloud platform, we need to use Wi-Fi module, which is going to interface this particular Arduino evolution board through UART communication protocol. Whereas ESP8266, we have inbuilt Wi-Fi, so that whatever data we are getting here, we directly push the data to the cloud. Whereas ESP32, it will be suitable. It is having both Wi-Fi and Bluetooth. This ESP32 is consisting having both Wi-Fi and Bluetooth, so that we can communicate through Bluetooth from one device to other device at the same time. As it is having inbuilt Wi-Fi, it is directly push the data to the cloud. That is what the advancements of this particular thing. So Arduino, ESP8266 and ESP32. If you want to develop your evolution or prototype, my suggestion is just go through, just use ESP32. It is having more advanced pins when compared to both ESP8266 and Arduino, and it is having inbuilt Wi-Fi and it's having Bluetooth. Okay, so these are the better suggestion when compared to the Arduino and ESP8266. Now we will get into the in deep about each and every module and their pins configuration. Let's get into the Arduino Uno. So Arduino Uno, it's a controller is Atmega 32P. So if you are seeing this particular IC, this is the heart of this particular entire board. Whatever board, Arduino board we are using, sorry. This is the Atmega 328P. This is the entire IC. This is the controller for entire Arduino IDE. So pins will be taken from this particular mounting points. As you are aware about PCB designing, we are going to mount this particular IC here, and from here to we will take the connections to this particular headers. So this is what the, sorry again, I guess this is the controller. Since the crystal oscillator is supposed to be placed near to the controller, so I guess like this
No,
sorry, this is the controller, right?
Yes, that is the Atmega controller, and that
Yes.
is an IC which need to convert the data from UART to USB bridge.
Yes. Okay, fine. Yeah. Sorry,
So
sorry guys.
what is IC in this?
Sorry, this one, the longer one. This is the controller on Arduino IDE. LPC, sorry, it's Atmega 328P. This is the controller on Arduino Uno board, and this IC will works for USB to UART conversion. Whatever the data we are receiving from external code downloading, so this IC will convert USB data to the UART. So give me a second, guys. Yeah.
What is that IC name, sir? Converting to
It's
what?
Atmega 328P.
Not that. Which is converting to what?
We can use.
That is CP2101 IC, ma'am.
Yes. We are going to discuss about CP2108 in the coming slides. Here we are having. Give me a second. This is what the IC CP2102. So we will discuss about in detail how to install those related software in the Arduino IDE. So basically, this CP2102 is basically convert the USB data what we are getting from computer. So this particular IC will convert USB data to the UART. So it offers this particular IC on Arduino. It offers only 14 digital I/O pins. So out of 14, 6 will support for PWM, pulse width modulation. And this is about using this digital I/O pins. We can simply connect LEDs, motors, and sensors through digital pins only. Okay, and it supports for 6 analog input pins to interface analog sensors. There are basically 2 types of sensors are there. One is analog sensor and digital sensors, and some sensors are supported with some protocols like I2C, SPI. So on Arduino Uno board, which is having Atmega 328P controller, It is having only 14 digital IO pins. Out of 14, 6 pins will support for PWM purposes. So for digital pins, we can connect either LED jumpers, LEDs, buzzer, okay, and different sensors, motors, everything we will connect to the digital pins. And it is having 6 analog pins. For these 6 analog pins, we can connect the analog sensors. So these were the basics of this particular Arduino Uno board. Now we will discuss about pins configuration. So just I request you guys to please go through this particular thing and let me know like what you are understand about this particular pin configuration of Arduino. So same thing for any industry grade controller. Meanwhile, you just go through it, what it exactly stands for. Get back to the topic again. So this particular control at mega controller, it is having almost all 30 pins. I didn't remember the exact count. So these pins will be having a connections to this particular header pins. You might aware about tracks. Okay, so every pin having multiple functionalities. So the black color one indicated here are related to the power pins. The reset, the 3.3, 5 volts, ground, and VIN. These pins are related to the power. So whatever the operations we are dealing related to the power, all terminations will be terminated here. So VN pin is there. So from using this pin, if we are able to give the power supply from either this jack or USB, they, like here we can give, there are 3 options to power up this particular board. One is regular power jack. Second thing is USB to UART converter module, this particular connector. And third thing is using VIN pin. Using VIN pin, we can power up this particular board. And ground is related to the input power supply, and 5 volts is the output termination here, and the ground is coming for both 3.3 and 5. The converted IC is here, 3.3 conversion IC. I'm unable to find it. IC might be placed at the back side. So this is the 3.3 regulator IC. This IC basically convert the this IC will basically power up, we will give the 5 volts as a input, and this particular 3.3 regulator will convert that 5 volts to 3.3, and the rest of the board will be work on 3.3. This USB to UART converter IC and ATmega controller and what are the remaining all ICs are working on 3.3 voltage regulator. So these were the 3.3 and reset. So these are related to the power. Now we will see about analog pins. So A0, it is having 6 analog pins: A0, A1, A2, A3, A4, A5. So these are basically analog pins. Okay, we can use SDA and SCL, serial clock and serial data. Basically, these pins can be used for I2C. So if you want to connect some temperature sensor which is having I2C, which is support to I2C, okay, we can use these SDA and SCL lines. So PC4 and PC5, pin connect 4 and pin connect 5, pin number. So basically the black color one support for I2C, the SDA and SCL. The green color one support for analog. The blue color one are used for the digital. We can use A0, A1, A2, A3, A4 as the digital pins. Okay, we can use it for digital or we can use it for analog. Okay, it's purely depends on the coding part. In the coding, we can define it is as the analog pin, or else we can define it as the digital pin. Analog or digital or SCA. Since these 6 pins are having 3 different functions. One is digital, second thing is analog, and third thing is I2C. Based on our external requirement, we can configure these pins through coding part. Okay. Now we will discuss about a reference, analog voltage reference. We can set the reference voltage here and ground. These are also related to the ground. So based on this reference voltage only, based on reference voltage only, entire board will works. It is like a base core voltage. Okay. Shai Shankar will give more explanation related to the A reference voltage if you are having any doubts. And thereafter, PB5, this is C block, B block, and D block. So in B block, the pins from B0 to B5, again 6 pins. There we can use for a general purpose digital pins, MOSI, MISO, chip select and clock. These 4 pins like PB5, PB4, PB3 and PB2 can be used for SPI communication. If we are having any sensor which is supported for SPI protocol, most probably all memory related devices are dealing with SPI protocol. So that we can use these 4 lines: SCK, MOSI, MISO and chip select. MOSI stands for masked out and slave in. MISO stands for masked in, slave out. SCK, serial clock, and SS, chip select, save select. So this is how those 4 pins. And at the same time, PB3, PB2 and PB1 support for PWM, pulse width modulation. We can use PB3, PB2, PB1 pins for pulse width modulation concept. At the same time, PD6, PD5 and PD3 can be used for pulse width modulation. Okay, and whereas PD0 to PD7 can be used for digital pins. So in total, dedicatedly 14 pins are there for digital IOs, and 4 pins for I2C, and 6 pins for PWM, and 2 pins for I2C, and 6 dedicated pins for analog, and 8 pins are dedicated for power. So if you are saying TX or RX, these 2 pins are related to the UART communication protocol, universal asynchronous transmitter and receiver. And INT1, INT2, INT0, INT1 stands for interrupt 0 and interrupt 1. These pins will be used for interrupt concept. So these were the pin configuration of this particular Arduino. So if you are having any doubts, we are open for 2 to 3 minutes. Thereafter, we would like to go for other pin configuration. So here is the quick question: how one pin will be active for 3 to 4 different functionalities? If you see PB3 and PB2, they are having 3 different functionalities. One is 11 and 10. Those are related to the digital pin, and they will support for MOSI and chip select, which is basically SPI. At the same time, they will be support for PWM. How one pin will be works for 3 to 4 different functionalities? Any guesses? Am I audible?
Yeah, actually,
Yeah.
it is multiplexed. It is a multiplexed thing. At a time, I can use for any one of the purpose.
Exactly. The multiplexing concept is, most of the people are aware about multiplexing in hardware configuration. So if you are having 4 inputs, but if you are having only 1 pin in the controller, let me give you an example. Like if there are 16 different inputs, but in our controller, we need to read all the 16 inputs. But in our controller, if there are only 5 to 6 pins are available, then what should we do? We should not connect all the 16 inputs to the controller, as there are pins limitation are there. So what we will use one multiplexer concept, 16 by 1 multiplexer, so that all 16 inputs will be connected to the multiplexer, so that we will use 3 selection lines, 4 selection lines from the controller: A0, A1, A2, A3, or S0, S1, S2, S3, 4 selections from the controller. So 4 pins we will be used from the controller. So based on the selection lines, we will get the output. So one output line of the multiplexer will be connected to the controller. So in total, we will use 5 pins. But the outputs are the inputs, basic inputs are 16. So all 16 inputs we are reading only using 5 particular pins. Those are 4 selection lines and 1 output. So these are the basic concept of multiplexer in the real time, when there are a number of inputs, 16 inputs, but in our controller, if we are having only 5 pins, at that moment we can't connect all 16 inputs directly connect to the controller. At this moment, what we will do is we will simply place 16 by 1 multiplexer is there. All 16 inputs will be connected to the multiplexer. So we will simply use 4 selection lines from the controller and 1 output of that particular multiplexer to the controller, so that only we will use 5 pins of the controller. These are we can read all 16 inputs. So these were the funda about hardware stuff, hardware related kind. What about firmware? If there in the controller, we can't keep all the 16, or we can't keep multiple pins for multiple functionalities. Only 1 pin will be used for multiple functionalities by simply keeping the pin mode. The pin mode can be output or input to the I2C, SPI. In the coding part, we will discuss what is pin mode. So by simply writing pin mode in the firmware, in the coding part, control will understand this pin is used for I2C purpose. This pin is used for GPIO purpose. This pin is going to use for SPI purpose. So by simply writing pin mode in the coding, control will understand how user is going to use that particular pin. That's how in the firmware logic, each pin is having multiple functionalities like digital IO pin, or else SPI, or else PWM. We supposed to configure this particular logic using firmware logics. So this is about pin configuration. So hope you understand. We will go for further slides. So real-time applications of Arduino IDE, we can use it for home automation. We can develop the weather station. We can go for environment monitoring, smart agriculture, health monitoring. We can do n number of applications using this particular Arduino. The thing here is it's limited for real-time use because of clock. The first thing, because of durability, and the third thing is it is having a limited functionalities and limited pins. Okay, and fourth thing is it's as a evolution kit. If you are going to use entire evolution kit, the size of the prototype will be bigger. Whereas in our PCB designing, we are going with how to design particular dedicated PCB. So if you want to use this particular controller at Mega 328P controller for our dedicated circuit, so that we will simply take this particular controller out and we can design our own customized PCB. The topic will be discussed in the PCB workshop, PCB FDP, so that the size of the entire PCB will come down, so that product size will become smaller. So that's why we are not using this particular Arduino for real-time applications, but for academic prototyping, as these are cost-effective and widely available. We can, as it is having terminations, so that we can do experiments in a quicker manner. That's why we are using these boards, these evolution kits, for prototyping purpose only. Now we will discuss about ESP8266, which is basically known as Node MCU. So basically, Node MCU is supported with Wi-Fi, is inbuilt on the particular IC. ESP8266 is consisting of on system on chip. It's built Wi-Fi, and it is having USB interface, and it is also having GPIO pins. And basically, it's a compatible. When you're seeing with Arduino, it's a compatible in size, and we can. It's a widely available and cost-effective and compared to Arduino. So as it is having a internet inbuilt, we no need to use external device for internet purpose. So that's what the beauty with this particular ESP32 port, ESP86 port. Now we will see about the pins configuration of this particular ESP8266. So basically, it is also support for power pins. So Vin, the red color one, are related to the power. Vin is there, 3.3 is there, and the black color one represents for the ground. And it is also support for GPIO, general purpose input output. So it's having a 16 general purpose input output pins, like GPIO 0. If you see, GPIO 0 is there, GPIO 1 is here, and GPIO 2 is here. Okay, GPIO 3, it will support up to GPIO 16. In total, there are 16 GPIOs are there. Whereas in Arduino, it will support up to only 12 digital IOs. It supports up to 16 IOs. Whereas coming to SPI, it's having SPI pins like MOSI, MISO, serial clock, and chip select. So here we are having, and it's also support for I2C, SCL, SDA. It's related to the GPIO 4 and GPIO 5 are also support for I2C. And along with these also have these pins also available in Arduino, but there are extra pins and extra functionalities. If you are simply compare both the things, so you will get there is a one ADC pin, and there are UART pins, RxD0 and TxD0. At the same time, RxD1, TxD1. It is having two UART pins on the controller board itself, and there are some control pins are there. Enable, reset pins are there. Wake pin, it's like interrupt, and flash pin. Okay, there are some pins are reserved for the future scope. So there are extra pins related to the memory, SGIO. The green color one, SDIO. SD3, SDD3, SDD2, SDD1, SD command, SDD0, SD clock. These 6 pins are related to the memory. We can directly interface our memory card to this particular GPIO 10, 9, 8, 11, 7, 6. So these were the extra feature we are having in the ESP8266. So any doubts? Okay, then we will get into the next topic. So these were the pins description of ESP8266. So there are a number of pins, almost all 40 pins are there. ADC pin will be used for analog to digital conversion. Here we need to give the analog input, and thereafter two result pins are there. I would like to explain pin by pin. Here ADC is there, analog pin is there, and two pins are reserved. And thereafter SDD3, SDD2, SD1, SDD command, and SDD0. These are like data pins and command pins. Same pins we can use it for a GPIO. Alternative functionalities are there. So these how every pin is having different alternative functions are there. Okay. So as time being, I just want to skip this particular pin description. I will share this particular PPT. I hope you get the concept of one pin is having multiple functionalities. I will share this particular PPT of the session. So these were the pins description of ESP8266. One pin is having multiple functionalities. We can configure the functionality of that particular pin using firmware, using pin mode concept. Now we will see about real-time application of ESP8266. So if you want to build a weather station using ESP8266, so we can develop a number of applications. Home automation is there, weather station is there, environmental monitoring and smart agriculture, healthcare, health monitoring and industrial automation, wearable device education. So there are a number of real-time applications are there. Here we are going to see one weather station is there. So for weather station, we are taking DHT11 sensor, which basically useful for temperature and humidity monitoring. So BMP 180 is generally useful for pressure. So both sensors will be interfaced to the particular node MCU based on the pins. Every sensor is having two types of pins. One is power related pins. The red color and black color one related to the power. Red one is related to the VCC, and the black color one is represented for ground. And the rest of the pins are used for signal communication. Some sensors are having support for I2C. Some sensors are having digital inputs, digital outputs, and some sensors are analog. So rain sensor is there. So rain sensor we are using conversion module is there. So we are taking data from train sensor to converter module. From converter module to we will have directly connection with onboard VCC, ground, and signal. The green color one is represented with a signal, and the red and black is related to the VCC and ground. So entire data, as it is having inbuilt Wi-Fi, if you are having external internet provision, if you provide some external hotspot kind of thing for internet purpose, this node MCU directly push the data to the corresponding cloud platform. This is how we will get the data in the cloud itself. The temperature, the pressure, the rain occurrence, and the humidity. This is what the basic application of ESP8266. Tomorrow we will go through coding. If you are come up with the Arduino IDE, so it will be easy for you guys to develop the coding on your own. So these were the basic weather station. Now we will discuss about ESP32 board, basically which is widely used nowadays because it is having Wi-Fi inbuilt, Bluetooth inbuilt. It is having more number of pins when compared to both ESP8266 and Arduino. Okay, and one more best feature is this controller is working on ultra low power mode. Basically all the IoT and embedded products or devices are basically need to work in the outside. Basically all are running on the battery. If even it's withdrawing 1 milliampere current higher, in the overall runtime, the overall life period of the particular battery will reduce by 1 hour, the performance time. Even if these particular ESP32 are working on the ultra low power mode, so that power consumption is less, the battery life period will be higher. Okay, so it's having multiple pins when compared to both Arduino and ESP8266. So these were the beauty with this particular ESP32 board. So these are the pins. So it's having widely available. There are almost all 40 GPIO pins are there. whereas Arduino is having only 12 or 14. ESP32 it's hardly having 15, whereas in ESP32 it's almost all support for up to 30 to 40 general purpose. At the same time, we can use every pin as analog ADC pins, and there are 3 UART pins are there, and enable power pins are there. We can use it for, there are touch sensors also there, touch 9, touch 8, touch 7, touch sensors also there, and it will support for 3 UARTs, and I2C supported, SPS supported, and PWM supported. Okay, these were the simple pin configuration of ESP32. So I will share this presentation after the session so that you will get into the detail. So it is also support for crystal oscillator. 32 kilohertz crystal oscillator also support with this particular ESP32 crystal oscillator 32. And you will directly connect it. Some sensors are there, sensor positive and sensor negative, and ADC related to the analog, and GPO meant for digital inputs, and SCL SDA meant for I2C, MOSI, MISO, serial clock, chip select related to the SPA, and some touch sensors. Almost all 8 touch sensors are there, and DAC1, DAC2. It's related to the digital to analog conversions are there. Okay, so when compared to rest of the controllers, it is having a wide number of n number of pins. At the same time, it is having inbuilt Wi-Fi. It is having inbuilt Bluetooth. This is what about ESP32. Okay, it is also having similar kind of applications. We can use it for a home automation. We can use it for a industry automation. Okay, we can use this particular ESP32 for data analytics, data logger as well. One of our product for Bangalore clients, Rockwell Automation, we developed energy logger using ESP32 only. So basically what energy logger is doing, in basic energy meter, they are having 42 registers are there. Out of 42 registers, different types of data will be stored in the energy meter. So we need to read the data stored in that particular register. So all 42 registers we are reading with only 2 pins. Those are UART pins, TX and RX. And that energy meter is supported for UART communication protocol. We are using Modbus communication protocol is there. We are extracting data from those 42 registers. And once we get the data here, and our controller will push the data to cloud platform. Basically, there are 80 meters back-to-back connection in the industry. The industry in Bangalore, in Karnataka government, they keep a proposal. Every industry supposed to submit their energy rated consumption to the industry, because many of the people are going for a huge production rather than regular regulations. They are going for a bulk production. When they go for a bulk production, the energy rating will be higher. That's why government supposed to make their all energy rated record on the online. That's why the clients reaching us, and we developed our energy logger using this particular ESP32. We are reading all 80 energy meters back to back within 5 seconds, I guess. Every 10 seconds, 5 seconds. Yes. Within 5 seconds only, we are reading 80 meters data, and we are pushing 80 meters data to our respective cloud platform, and we are there giving reports for analysis purpose, and we are sending same data to the government portal as well. These were the applications with ESP32. That's what industry automation. Okay. If you are interested, I will share that energy logger in tomorrow's session, how we are doing. Okay. So how we are reading the data and what exactly that energy logger. In tomorrow's session, I will try to show our product, energy logger product. Now we will discuss about how ESP32 and 8266 is different to each other. So whereas clock frequency, ESP32 is support up to 240, whereas ESP866 support up to 80 megahertz. And ESP32 is having Bluetooth. ESP866 is it's not having Bluetooth, and it is support for Hall sensor. There is no Hall sensor support, and we can interface. We can interface camera. Camera provision is not suitable for ESP32, and there is one module which is directly comes with ESP32. Camera module also support for ESP32, and touch 10 touch sensors are support for ESP32 and there is no support for ESP32. These were the different comparison between ESP866 and ESP866. You just request you guys to please go through. Whereas total GPO 39, whereas 17 GPOs are there on ESP32. So it's a low power consumption. ESP32 will take 10 microampere current, whereas ESP866 will consume 20 microampere current, almost all double. So request you guys, as we are running out of time, we will discuss about Arduino IDE installation in tomorrow's session, like how to install each and every step. So request you guys try to install this Arduino IDE tomorrow morning slot. I will share this document in the Google Drive. So request you guys to download the Arduino IDE and install all the needful packages. So step-by-step installation is there. So if you are come up with the Arduino IDE installation, tomorrow we will discuss about CP. You just go through CP2102 installation as well. Thereafter, tomorrow we will discuss about how to write the code for basic LED on and off. Tomorrow we will discuss about these particular two things: software installation and the basic coding. So as of now, in today's session, I just want to give a quick info. We are discussing about 3 boards: Arduino, ESP866 and ESP32. Arduino is a basic general purpose board, whereas ESP866 it's support for Wi-Fi, whereas ESP32 it's both Wi-Fi and Bluetooth. They are having different pins. Here Arduino Uno is having a controller called Atmega 328P, whereas ESP32 is ESP32 itself, and ESP866 the controller name is ESP866 only. Here we are discussing about different pin configurations and the functionalities, and how ESP32 is different from ESP866. This is what we discussed today. So now I'm open for questions for this particular topics. Yeah. Any doubts? Any doubts, ma'am or sir?
No, sir.
Yeah, thank you. Tomorrow, request you guys to please come up with the Arduino IDE installation so that we will start the coding. Lavanya ma'am, any doubts?
Simulation in simulation, not simulation. Whether we have the Arduino IDE in Walkthrough simulator itself.
Yes. Walkthrough simulation we have.
Okay.
Yeah, we will go through like both real-time coding. At the same time, I would like to explain the concept with Workway, so that if you are having no software and no hardware, then you can do the working on the Workway software. So the major agenda for tomorrow's session is writing the code. So how can we control the coding? How can we control the different things using coding part? If you are having Arduino IDE and hardware, that will be perfect. If you are unable to maintain both the things, then I would like to display both the things using Workway software. Okay.
Okay, sir.
Yeah. Any other?
Sir, is this possible to integrate Arduino Uno with ESP32, sir?
Yes, sir. It's possible. The thing here is there are 2 possibilities for interfacing. The first thing is ESP32 is support for Wi-Fi and Bluetooth. Arduino, if you are taking one extra module for Wi-Fi, so this is also Wi-Fi enabled, this is also Wi-Fi enabled, ESP32 and Arduino. So both will be communicated through wireless. That's the first scenario. And the second scenario is this Arduino support for UART, and ESP32 is also support for UART. So if you want to go with a Y-to-Y communication, this TX is supposed to connect with RX of ESP866 or ESP32, and the RX of Arduino is supposed to connect with TX of ESP32. That is the wired communication. So either we can go for a wireless interfacing or wireless interfacing based on our requirement. Okay, based on our possibility, we can interface. Like the thing here is, if there are limited pins are there, if you want to do some more operations, then for Wi-Fi purpose or for Bluetooth purpose, we can use ESP866 or ESP32. For data interfacing or sensors interfacing, we can use Arduino. We can configure a number of ways. Okay, am I clear, sir?
Yes, sir. Actually, I purchased one ESP8266 only Wi-Fi module, sir. Actually, instead of controller, I purchased a simple ESP8266 Wi-Fi module, sir. Actually, it's 8 pins around. Actually, little bit they in this module they did not mention where is the DX, where is the RX. A little
Yeah,
bit confused.
we will help you. We will help you, sir. After this particular meeting, please share your query in the WhatsApp group, so that if you are having any emails, please let me know, so that we will put the pins description. Every controller, every IC is basically having pins. Okay, so I would like to explain with presentation again. So if you are taking this particular IC, there are pins mapping will be there, pins configuration will be there. This pin 1, pin 2, pin 3.
Actually,
Okay.
I know this type of material, sir. But actually, I purchased only that Wi-Fi transfer
Yes, yes.
module.
Got it, sir. Only Wi-Fi model is also having pins configuration. So these evolution boards are basically placed that ICs on the particular evolution board. But in your case, you are directly purchase the bare IC.
Yes,
The
sir.
independent IC you purchase. You are unable to find which pin is used for which purpose. So
Yes, sir.
no need to worry. Every IC is having its own data sheet. So in data sheet, they will mention about pin configuration, so that we will directly take the pins configuration, we will directly take the tapping, and we will do the function whatever we need. Okay, either we will go for as it is a independent IC, we supposed to give the power VCC and ground. Okay, that's the first thing. We need to do it from Arduino, as you are having Arduino as the main controller. Atmega is having a main controller. We need to power up this particular IC. So VCC and ground, you supposed to take it from your main controller board Arduino, and the UART pins TX RX. We supposed to find the pins, and we would like to take the wired communication only. Okay. So we will help you out. So after this session, please take your IC photo and module number, so that we will help you out with pin description. Any other doubts? Yeah.
Sure, sir. Thank you.
Yeah. Your good name, sir? Arul.
Sir, Arun
Yeah,
Murugan,
from which state, sir? Tamil Nadu?
Kongu Engineering College.
Okay, fine, sir. Fine. Any other doubts? So any other doubts? Shai Shankar is ready with PCB. So we'll take 2 minutes of time to explain about our summer training cum internship activity. So every year we are conducting our summer training cum internship activity for basically engineering students and degree students. Our major focus on EC related stuff. One is we are hosting 4 summer training cum internship. One is industrial IoT, and the second one is embedded systems using ARM Cortex M3 M4. Like most of the outsiders will saying this Arduino and ESP as embedded, but these are related to the prototyping. Real embedded systems are dealing with ARM Cortex M3 M4. We are working on ARM Cortex M3 M4 controllers in our industry. Those are like LPC 1768, LPC 1769, STM32. So these are what embedded systems using ARM Cortex M3 M4 controllers. And the third summer training cum internship activity is FPGA based VLSI design. We are basically using five types of FPGA board. They are D10 Lite, D10 Nano, Edge board, Nexus 4 DDR, and few more boards are there. We are working on those boards. And the fourth summer training cum internship activity is System Verilog. In these 4 domains, we are offering 45 days summer training cum internship activity. So it's like a skill enhancement for both engineering first year, second year, and third year students. So it's as it is a 6 week summer training cum internship activity, 4 to 5 weeks will be covered in the online mode. So entire theory, coding, simulations, entire explanation will be covered in the online mode in the live interaction sessions. We also provide recording sessions to the students. So 1 or 2 weeks based on the students' availability, they are supposed to come to the offline centers. Our offline centers are Mangalgiri, Vijayawada, and Hyderabad. So based on student availability, they can directly come to their available offline centers and they can do their hands-on. Okay, and we are launching in 4 different batches. One is May 1st batch, May 10th batch, May 25th batch, and June 5th batch. Based on student curriculum availability and exam schedule and holiday schedule, they can choose any one of their dedicated batch, and they can select their independent summer training cum internship at their desired location. So basically, it's a live interaction session, and we are providing hands-on sessions for the students. So you are aware about how we are dealing for faculty, and we are not a regular training institute. We are basically broad-based company. Yeah,
One
no,
doubt. Actually, I'm interested in STM32 and
yes, yes,
FPGA boards.
yes,
So
yes.
yeah.
STM32 is covered in LPC 176 ARM Cortex M3 M4. There is a summer training internship called Embedded Systems using ARM Cortex M3 M4. So M3 we are dealing with LPC 1768 and M4 STM32. Those two things will be covered in the embedded systems. And whereas FPGA we are working with six types of FPGA boards. So that will be again something different. FPGA based VLSI design. So
Yeah.
it's we are
Which board
yeah.
you're using? FPGA?
Sorry.
FPGA, which board you're using?
Like we are dealing 6 varieties for student training. One is D10 Lite, D10 Nano, Edge board is there, Nexus 4 DDR, and there are 4 more advanced boards are there.
Okay.
Okay, and one more thing, it's not a only 45 days of activity. We would like to give you a long-term support for the students. As individual, as company, we cleared 15 nationals and international competitions, so that there are n number of competitions are available, n number of hackathons are available from the government of India and different private organizations. So that we have clear idea how to tackle these particular competitions and grants. So that we will redirect the top students for those particular competitions and grants with innovative ideas. That's the first thing. And second thing, we will have the students to write their own publication. So every summer we are publishing around 50 papers, which are basically UGC care, which will be helpful for the faculty as well. So every year we are publishing 50. This time we are planning around 130 to 140.
So even if we are interested, sir?
Yes, you can also join, ma'am. So competitions grants are there, and publication support is there. And third thing is for the top performers, we will hire for our organization. And every year we are sending 80 profiles for different companies like Enlight Devices, Mossip, Qualcomm, Intel. Okay, we have closely working with 23 companies in EC and electronics core domain. For the top profiles, we will directly hire, and some of the profiles will be to the different collaborative companies based on their requirement and student performance.
So what about the cost perspective?
Its cost is not more than 5,000, I guess. Like different courses having different costs. Like IoT around 4,000.
Whether the in offline you are telling no, they need to come over there.
Yes,
They
yes.
need to stay. What
Yes.
about that, sir? Okay, online it's okay.
Like online, it's offline. It's purely depends on the student's interest, sir. If the students are feeling like
Okay.
if they are interested, if they want to come to the offline, they can directly come here and they can do the hands-on. And one more thing, if the students from the same institute or same region is more than 50 or 100, like we are going to conduct one offline center there itself. If you are from some university or college, if you are getting 50 to 100 students,
Assuming that if I am providing some kind of 50 students, especially
yes.
for ARM Cortex,
Yes.
you are telling ARM Cortex,
Yes.
then what else you told, sir?
Then entire online will be covered in the summer vacation. So once the students come to the academics as a workshop activity or else summer training activity, our team will come there with our own hardware kits. So that
How many days?
it's a 6 days only.
6
1
days
week.
you will come over here and you
Yes.
need to organize this
Yes.
ARM Cortex and other controller
Yes.
boards.
Yes. If the students count minimum 50 to 60, then our team will come over there, because moving all 60 to 100 students to our location, it's better to
Yeah, that is why I'm asking, because
Yes,
they need to
if to-
stay no.
Yes, 5 to 6 mentors there, and it will be helpful for you guys. Like we are customized everything. So if the students are enough, like we can go for a further MOU for further collaborations.
Okay, regarding FPGA, sir, FPGA, whether can you do some kind of FPGA? Everybody know curriculums they are studying, but they don't know how
Yes,
to interface with the real-time signals
Yes.
as well as images, etc. Whether
Yes,
you cover that.
Yes, we will cover. We will cover, ma'am. Basically, our major agenda is as we are developing some of the recent times. In recent times, we deployed one of our product to the NSIC Hyderabad. We deployed smart critical kind of thing, digital system for blind people. There, we are keeping one camera. It's going to do the image processing. It is using Wi-Fi and Bluetooth communication protocols. It is supposed to interface with communication protocols. I2C, SPS support protocols is there. We will discuss from base to advanced level. As those 4 to 5 weeks, we will cover entire thing. How to develop the coding, what are the communication protocols, what is the FPGA boards, and what is the software, how to install all those stuff. We will cover everything in the online so that students will no need to spend extra money for the food and accommodation at the outside. Once they are aware about all the coding stuff, simulations, everything, then we will come up with our hardware, or else we will invite the students.
How much time will you take during online, sir?
Online? It's a 2.5 hours in the morning slot for entire theory coding, and the afternoon slot 2 hours for doubts clarification and mentoring support will be there. One-on-one mentoring support.
In the month they won't get a holiday, so holiday very difficult. Okay.
Sorry.
1 month it is very difficult to get holidays, sir. Vacation.
Actually, thing here is like in online also we are planning 2 different batches. One is academic. During morning slot is there, afternoon slot is there, evening slot is there. They can join after their academics. Evening 6 to 8 o'clock session will be there. Okay. If you are providing bulk student, you can directly join after 6 p.m. to 8 p.m. session. Like same.
It's okay. But anyway, per day it will be 2 hours. Am I right, sir?
Per day 2 to 2.5 hours.
Okay.
Without disturbing academics. If they are having limited number of holidays, without disturbing their academics, we can plan in the after academic hours. Same as our FCP.
Okay, sir.
So every year, minimum 4 to 5 companies are visiting our summer training camp. They will hire almost all 50 to 80 guys. This is what the regular tendency. We are developing a curriculum for purely based on industry requirement. We are closely working with ARM Cortex M3, M4 controllers and FPGA boards, and system Verilog is there. Okay. For degree students or first year and second year students, the PCB designing and IIoT is suitable. For third years and fourth years, these are ARM Cortex M3, M4 and FPGA is suitable. First year and second year, PCB designing and Arduino. These are the basic level of intention, I can say. Yeah. If you are having any doubts, our Surya will get back. Okay. So Surya, could you please share our poster in the group? Today only we share everything in the WhatsApp group so that you can contact Mr. Surya. He's taken about the summer training comments. Surya, are you there?
Yeah, sure. I will post the entire details along with our poster and brochure with my contact details too.
Yes. Sashankar, would you like to share anything regarding our summer training mentorship?
No, sorry, I am in mute. Hi guys, good evening. The main intention of the internship, the training session, as you guys are already aware, there are a lot of institutes, a lot of training platforms in the online where they can provide this kind of information. But the main intention of ours to give in real-time practical knowledge to the students, where to fill the gap in between college level students to the industrial requirement, where if we have already observed since very long years, where there is a little bit gap which is slowly exponentially increasing in between real-time industrial needs to the curriculum basis. So where even though there are a lot of colleges and universities trying to fill those gaps by keeping such kind of PCB designing or VLSI designing or controller basic operation coding in their curriculums, but even though those are giving the theoretical knowledges, but they were not covering the real-time implications and the scenarios. So we want to put forth those kind of informations and such kind of things in front of the students that will helpful for the students to fulfill that gap, and that will help them to crack the jobs even better in better case. The main motto is to feed the knowledge to the students. Yeah, on top of that, if there is a very better students, by naturally they will procure the knowledge and they will place into very good jobs. if some students are facing any difficulty in placing the jobs even with a very good knowledge because of some issues with respect to communication or with respect to some other things, we can help them to get into a proper job, like how Sudhir have been previously explained. But the main motto or the main concept is to fulfill the gap and to give the knowledge to the students. That is what we are thinking to.
Yes, exactly. So academics, like you guys are is basically busy with our academics. Like you won't find your time for the this kind of industry level training. The thing here is you guys like really appreciate it. You are spending some extra hours of your time. Like you are a bit busy from 9 a.m. to 6 p.m. With your academic activity, teaching activity, and there you are joining in our FDP. Really, hats off to your efforts. The thing here is there are limited faculty. I find like there are limited faculty, those who are really interested to spending their time for student skill enhancement and student job aspects. There are limited faculty are there. Like there are 300, 400 registrations are there. Only 40 to 50 faculty members are joining here. And this is what the difference. And thing here is we are not focusing on training activity. It's a training come internship, and it's not only recording sessions. Live interaction will be there, and hands-on will be there. Publication support will be there, and we are sending profiles for the hackathons and competitions, and a number of companies are visiting to our summer campaign. So it will be easy for the students. Like if we started from now itself, coming 3 to 4 years, India is going to be boom, hit the market, entire world market in semiconductor domain. We need to start work. Like if you want to be live in the EC department, like nowadays we are unable to find the mechanical and civil departments anymore in the engineering college. Most of the engineering colleges are like a CSE colleges rather than EC colleges. Most of the engineering colleges are simply like a CSE colleges. So, but coming 3 to 4 years, India is going to be like a market for entire rest of the world. So now only we need to start working towards PCB designing, industrial IoT, prototyping, and LPC 176 ARM based and FPGA based. Then it will be easy for the students and industry as well. Like we know after COVID pandemic, most of the industries are thinking like ready-made guys. They don't want to train the people after hiring. They simply want to hire the people who are already trained. So things are changed after the COVID pandemic. So we are ready to move to your location if you are providing good number of students. At the same time, we would like to looking for a long-term collaboration for product development at your campus level itself. If we are started now itself it will be fulfilled within a year. Like the culture, the ecosystem, the startup ecosystem, the product development ecosystem. It will take time, but if you are maintaining some, we are major focusing on long term and consistency. That's why we are still in the market when compared to there are a number of people who are simply providing intensive certificate at 100 rupees and 200 rupees. But we are not compromising in the quality. We are not compromising on the learning segments. That's why we are keeping something higher, but that includes online, offline, publication support, and support for coming 1 year for publication and competitions. And one more thing, we don't want to sell final year projects. We are ready. The students should build their own final year projects. So many of the people are charging around 10,000, 15,000. They simply build the final year projects and they will simply give it to the students. But in our case, we will give the training, and students supposed to develop their own products, own projects. So that is what our commitment towards the learning. Okay, thank you guys. Mr. Surya will share everything in the group itself, and thank you so much. Yeah, Mr. Sai Shankar, please go ahead with your today's topic. Thank you, everyone.
Hello guys, good evening. Yeah. Have you guys completed the assessment, like the feedback form? Is still any of you guys are having any difficulty or facing any problem to submit the first assessment or having any doubts related to the first assessment? If anyone having any doubts relating to the drafting the schematic and drafting a symbol as well as creating our own footprint, please let me know. If we have any doubts, we will clear on those doubts and we will be going further ahead. I'll be waiting for three to
Actually,
four.
actually, we didn't know. I didn't know regarding this. So can we do it tomorrow? I didn't complete that. Yesterday, I didn't watch fully.
Okay, ma'am. Okay.
Sir, for creating symbol and footprint, no?
Yes.
Can you say again that dot for that square rectangle I have created, sir? But when
Okay,
I'm
ma'am.
creating another rectangle, that size I cannot able to say it in the same x-axis. Why?
Okay.
I don't know. That there I have stopped, sir.
Means is it's going
How many
somewhere else, ma'am, as you are saying?
No. Yeah, first I will create a rectangle, sir. And
Okay.
another rectangle, the pad for pad.
Okay. Yes, sir.
Another rectangle, same, it is not coming same line. It is going up or down.
Okay.
Same axis, I am unable to do that.
We can also enter manually x-axis and y-axis position on the right side of the properties, ma'am. If you have entered 0 in the y-axis and if you
This is for pro edition or standard?
in the both the editions, the options will be there, ma'am. In the both the versions.
Okay, sir. That
Even
alone
if you have
just you locate, sir. I will see that. Then we will create. Other things are known.
okay, ma'am. Even I will just show you. Where is that option will be? Mhm. Any other doubts or any other faculties? Are you faculty? Is this PCB session or this IoT session? Are you faculty are thinking it is helpful for you guys, or is it is having any other needs to be added for you to things, or is there any such kind of open feedback?
No, I think in this way, if we proceed, it will be useful, sir. But one more thing, that is some kind of controller, no? By selecting the. But anyway, everything becomes schematic. Yes, sir. That is footprints. Means we need to put it. That's all.
Yes.
Big circuit, I am asking.
Yes. We are thinking to go for a big circuit, but before going
And
for
will
a
you
big
cover a multi-layer and a multi-layer also, no, sir? Later.
Yes, ma'am. If based on we will be going to explain the things which will be really required. On top of that, we are having a small circuit as of now. After completion of this, we will be creating a new schematic, which is a bit complex than this, than real-time application based oriented kind of stuff. I am thinking to have a schematic of USB to UART converter itself, where I recently have developed for one of the client. Where is kind of a multi-layer PCB, which is really application-based oriented, which is by using CP2102 IC. That
Sir,
will
for
be
USB to UART converter, maybe the complex circuit, is it complex? So,
sorry,
or
ma'am.
otherwise the type. No, the circuit is very big, or you want to make it in a smaller, lesser size. That is why you have gone for multi-layer for that USB to UART.
That is where a simple circuitry we can make, as well as it will be easy for you guys to understand in the initial phase of learnings. On top of that, if time permits for us, we can also design a multi-layer PCB like for 4-layer PCB. But in easy EDA, it will be bit difficulty to explain in the multi-layer PCB also. But RTM will give that advantage to explain in multi-layer and to understand very well for the beginners to see the things.
I think parallelly also as you told that you can create the same circuit and other things in Altium and close it
Yes,
and
yes.
that
Yes.
way I think it will be helpful.
Yes, yes.
Useful, sir. Usefully, this information nobody will tell. Already otherwise they need to do online tutorials and nobody is doing. No, that is why they need to use this as an opportunity.
Yes, yes, ma'am. Thank you.
Thank you, sir.
Then any other doubts? Even we'll be having a short session today. We're going to the session. I will share my screen and I will show you the regarding x-axis and y-axis. Okay. Once have you selected this pad, you can see the location option, ma'am, here, where center
Yeah.
X and center Y
Yes.
in the Pro version. As well as in the standard version also, it is having same kind of nomenclature, center axis and Y axis. Here you have to select Y on 0 and center axis as per the distance from pad to pad.
Okay. Okay. I think some value may be there. I don't know. Okay. Let me
No,
check.
you can check it. As in the beginning phase, we will get bit confused over lot of options and we will forget few options too. That is anyhow by natural it will comes. By doing it on a practice level and by doing in and day out, we will be habituate of doing such kind of things, ma'am.
So this rectangle also you will copy and paste. You can copy and paste, no?
Now we can copy and paste.
Copy
Yeah.
means this is Control C.
Control C, Control V in general way.
Okay. 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 Now I have taken that click on that rectangular box, but I have said Control C. It is not copied. I don't know why. Okay.
Okay. Okay. Now we will be sharing our screen for. Okay. Today we are going to cover few advanced PCB design constraints which need to be followed before generating a Gerber and after doing a placement and routing thing. Yesterday we have covered at how to do a routing for a minimal PCB and lot of things. And there are, after completion of routing, we can create a Gerber file. But before creating a Gerber file, we have to know few more design constraint rules also. Those were what we are discussing today. After discussing this theoretical part today, tomorrow we will be having another session to create a Gerber file, means the actual output file of the PCB, and we will see what are different kind of output job files it will be creating, what is the importance of each file, and we will look into detail of each and every component, and we will also going to explain what are the parameters need to send to a fabricator and how to order a minimal PCB, such kind of things also we will see. And on top of that, we will see how the manufacturer will design a PCB, or sorry, fabricate a PCB, and how they will manufacture a PCB in the real-time industry. After all of this, a complete cycle completes. No? So after that, we will take one more example of a circuitry, and we will select our own components, and we will select the resistor values, diode values, capacitor values, whatever it requires. We will do design analysis for a circuitry. We will draw our schematic. We will draw our first layout, and we will create our own job output Gerber file, and where you can order for yourself based on your requirement if you want to. But that will give you a complete confidence level or complete knowledge over in PCB design. This is very high level or not high level, sorry, in deep level understanding of a PCB. Okay. Today we are going to cover that high speed PCB design principles, even though we have covered like highlighted points yesterday, and we will be covered related to signal integrity, EMI and EMC related one, and thermal management and heat dissipation strategies. What are the different kind of approaches we will be usually follows on the PCBs, and PCB design for manufacturability, usually we will call it as DFM, and the cost optimization of the PCBs. And how should we think in such a way? We will look into them in detail also. And mechanical aspects of the PCB design, kind of when we are designing with enclosures, mounting holes, connectors, and the case studies for the optimizing a PCB for industrial applications, where we will be going to cover today. The high-speed PCB design principles, like for signal integrity, where control impedance is much more important, as well as so vital when we are designing very high-speed signals, ensuring the transmission lines have consistent impedance to avoid the reflections and signal noises. Reflections means usually when we are, for an understanding purpose or for an analogy purpose, I will give you an general use case scenario. Few guys might already aware of eddy currents. The eddy current is kind of opposing current to an actual current. In similar manner, when a signal is passing through a track, when there is a sharp edges or where there will be a high impedance on your track, that will lead to having reflections of the actual signal, which will distort or which will disturb the signal itself, and it will lead to signal noise as well as also loss of the signal, and minimizing the crosstalk. As we already discussed what is meant by crosstalk, we have to minimize the crosstalk using proper trace spacing and ground placing to reduce the EMF coupling in between the signals, or electromagnetic coupling between the signals. And termination techniques, implementing serial or parallel termination to match the impedance and to reduce the signal degradation. While with respect to referring to the first point, like control impedance, the termination technique will help to control the impedance and reducing the reflections, where the second point is fourth point is interrelated, like avoiding the abrupt changes in the track width and unnecessary wires to maintain a smooth signal path. If you are creating a track which is of, let us say, 9 mil, and if you have suddenly increased it from 9 mil to 16 mil, by definitely it will having issues with respect to the reflections of the signal. You can also check the information in the slides as well as with respect to pictorial representation, which is having a termination resistor and smooth track termination without having any wires on the line. Okay, which also having the minimized crosstalk and controlled impedance on the PCBs. And while we are talking about EMI and EMC topic, this is one of the major constraint and major problem caused in real-time industries, because of, even though when we have designed all the circuitries, ideally they should work as per our requirement guidance. But with respect to real-time scenarios, there will be a lot of governing factors on EMI and EMC, which will degrade the performance of an PCB, or which will try to damage the PCB in the real-time scenarios. We will see how to address those things, like by providing a proper grounding and shielding techniques, filters and decoupling on the things, and differential pair routing, layer stack up considerations. By taking all of these parameters, we can at least address these issues of EMI and EMC. Even though there are a lot of standards for this EMI, EMC to test the PCBs, like to apply air discharge, contact discharge, as conductional discharge, and radiation discharge. These are kind of high level nomenclatures of these testings. Even though in each discharge level, let us say if we are talking about an air discharge, there will be a discharge of EMI like 8 kilovolts or 20 kilovolts or 15 kilovolts. There will be, based on different standards, there will be different ratings need to be applied on the PCBs. Okay, you can also see there will be an emission that can be occurred from a PCB towards outer side, or there can be a chance of absorption of EMI or EMC from external environment to a PCB. Either the way, they will create an issue on the PCBs. You can see the shielding. Usually the shielding is nothing but, in the previous class, when you have observed that with respect to that ESP32 or ESP86 modules, where it is having a silver color a coating on the module. That is nothing but a shielding which provides a protection towards EMI and EMC with proper grounding plane of a shielding, and maintaining a differential pair routing as well as solid ground plane connections also. Where you can ask us like why, how a differential pair routing can reduce the noise or an EMI effect on your PCB. As we already discussed yesterday, like the transistors, by evolving of your transistors, by evolving of op amps, which gives an advantage of CMRR technique in the electronics, which means common mode rejection ratio. Even though let us say there is a noise induced on a single line, if we have maintaining a differential pair routing, that will induce on both both the lines, on the both positive line as well as on the negative line. So where CMRR will take care regarding those common noise on the line, and which will eliminate it, and we will get the actual signal on the data. Okay, where this is one of the kind of testing scenario where there will be a source of creating an EMI EMC testing, and victim is nothing but our PCB or our design hardware setup, where it will be going to induce in radiated EMI or induced EMI or conductive EMI or capacitive EMI. Either the way we can test and we can evaluate the PCBs.
Sir, actually, for this, you are telling that the differential pair routing, no?
Yes, ma'am.
Maybe okay if I am using multiple transistor and all. Operational amplifier already is having high CMRR. That
Yes,
is
ma'am.
there. Whether for that also we need to use this differential pair routing.
No,
Is
no,
there
no,
any
ma'am.
device specific? No.
No. I am saying because of op amps. As of op amps means we no need to use an actual op amp on the PCB. Let us say if we are using an Ethernet module, or let us say if you are using an USB module, internally itself it is having an op amp based circuitry. Because of that, it is having a high impedance, high input impedance. So by naturally, because of that advantage in that ICs, this we can use that advantage for our PCBs to eliminate such kind of scenario. What I'm trying to explain.
Okay, sir.
Okay. And thermal management and heat dissipation strategies. Have you? We already discussed regarding the thermal management and heat dissipation like yesterday or day before yesterday. Did anyone can address related to this issue? How we can address, or what are the different kind of possible scenarios to eliminate these thermal issues or heat dissipation? Have you ever seen? Sorry, ma'am?
Via.
Yes. Very good, ma'am. And any other? In our day-to-day life also we seen lot of things, lot of techniques. If we seen few PCBs.
Heat sink usage.
Yes, very good, sir. Heat sink users. Any other? Okay. Usually, as we already discussed, by using to the heat dissipation is one of the vital thing we have to consider when we are designing a PCB. Because let us say if a component is working on a temperature of an ambient temperature of 40 degrees and it's creating a junction temperature of more than an ambient temperature, it will lead to degrade a component on daily basis. Let us say if we are operating an component at a 25 degrees of an ambient temperature and it is creating a junction temperature of 40 degrees, the component can survive up to, let us say, of 10 years. But if you keep on increasing a temperature, let us say the ambient temperature itself is going a rise and the junction temperature is going beyond its limits, the lifetime of a component will be degraded from 10 years to 5 years, even though it can be even less. So we have to think in such a way for the degradation of a component as well as the PCB things. Even sometimes the heat which is generated from the same component may not having effect on its own IC, but it will be having effect on the nearby ICs. Even though the temperature is generating from another component, let us say there is another component which is very nearby when we are placing a component, that might having this heat effect on the other component, and that will be going to degrade. So we have to address the thermal issues by using thermal vias, or by using heat sinks, by using copper pores or the copper planes, by using thermal pads or conductive materials, and by using a component placement by properly and strategically to avoid the hotspots. Here hotspot is nothing but a very heat component generated particle. And in very advanced technologies, like when we are talking about in server data, like servers or databases which are running in very high processing things, wherein liquid based cooling mechanism is also available in the market, but that is very highly heavy, expensive and very cost approach method also, but that will definitely give you a better result as well. As here, by seeing a heat sink in the first image, kind of image A, where we will have multiple fins. By creating a multiple fins where air will generally flow and it will be cooling a component and which will dissipate our heat, or we can use thermal vias, or we will use in copper inlay and material substrate also. And general approach, usually we will use in exhaust fans or a cooling fans on a component, like how we our CPUs, on top of CPUs we will usually place a fan to eradicate the heat of the processor. If the processor is going to be heat and if the fan is not running, by naturally you can see the process delay or the system is going to be lag. That such kind of scenarios even we can see in the embedded PCB design too.
Sir, while doing copper pouring,
Yes,
how
ma'am.
do you say that it will dissipate the heat, sir? Because it increases the area
Yes,
of the
ma'am.
conducting plane.
Yes, ma'am.
How does it reduce the heat?
Okay. We will talk it in, let us say we will talk it in very general use case, ma'am. Okay.
Okay.
Let us say we will take some, how can we will say, usually in generally, if there is a very solid copper, we will take some steel bar, or we will take some steel plate for general purpose. Let us say we kept a very hot component on a single steel plate. Let us say the steel plate is of 1 square feet, and we
Okay.
kept a small heat object on that square feet component, and we will take another steel plate which is of 2 square
Larger
feet.
size.
And if
Okay.
you keep the same component on the another plane, by naturally the heat of the component which is placed on the plates, which will be getting cool quicker.
Okay. Okay.
You
Okay. It
understood,
will
ma'am?
get heated. It will get heated, but anyway, it will dissipate immediately.
Yes,
Because
because of the
the area
dissipation
is
plane
larger.
is higher.
Okay.
Because of the plane is higher, the dissipation is also higher. It will get cooler
Okay.
quick.
Okay. Got it, sir. Got it. Yes.
Okay, ma'am. As we already discussed, even for the high power components like MOSFET, we will use the heatsink heatsink plates or heatsink components, as well as by using thermal pads or a conductive materials. And we will also provide a component placement strategically to avoid the heat components from a sensitive components also. And there will be another technique called thermal pad and conductive materials. By that also we can eradicate these thermal issues. But usually that is if we are dealing with in heavy temperature components, such kind of scenarios only we will generally use this thermal pad or the conductive materials, usually because it is very expensive, and usually the manufacturing process is also very limitedly resources available. Okay. And as we already discussed, we will generally use the fans to cool up the things, as well as if you have seen, if there is an heat generated on a component, it will dissipate on a PCB, like with respect to the arrows, how it was going to be dissipate on the actual PCB. If a copper plane is completely, if we have a long copper core, it will be completely disposed and the heat will be dissipated very easily. And few cooling methods like passive cooling, active cooling, heat spreading techniques. The passive cooling is like using natural conventional by optimizing PCB layout and copper core. and active cooling by incorporating fans or liquid cooling for high power applications, and heat spreading techniques like utilizing thermal wires and heat pipes and to distribute the heat evenly. These are the things same way as we discussed, but these are three main categories. All of them will be come under these umbrellas. Okay. And PCB design for manufacturing and cost optimization. Sorry, guys. And the few standard guidelines need to be followed, like standard trace width and spacings, via designs, as well as component spacing, panelizing, and shoulder mask and silk screen considerations. I will address like what is meant by panelization and each and everything in detail. In meanwhile, you can have a look on the image which is on the left side. Okay, I will be back in 1 second, please. Okay, sorry guys. Yes, the standard trace width and spacing means following the manufacturer recommendations for the trace width and spacing for the reliability of the component, as well as via designing using standard via sizes and avoiding unnecessary blind or buried vias to reduce the complexity. Here we already discussed what is meant by via, and there is another technique called blind via or buried via. Blind or buried via is nothing but where we will have a via, but we will keep closed without giving any, like from layer to layer via, or we will be green mask the complete via, which will be lead to issues when we are debugging the PCB or when we are evaluating the PCBs. So we should avoid such kind of blind or buried vias until and unless those are really required. Those are not recommended to use on the PCBs. And component spacing, like providing an enough clearance between components for easy of soldering and assembly process. When we are talking about an assembly process of an PCB, we will be addressing this issue again. We will be talking regarding this, and we will be focusing on this once again. Panelization is nothing but like when we are designing a PCB, let us say it might be a very small PCB or it might be a very big PCB. The panelization is nothing but kind of an having multiple PCBs on a very big plane. Like we will be make it into a chunk of pieces to which will help us to do the batch manufacturing as well as minimize the material wastage of a PCB. For a general scenario, I will show you how the panelization looks like after the completion of this PPT. And we will the soldering mask as well as silk screen considerations, where soldering mask need to be keyed for each and every component to avoid the soldering bridges when we are doing the soldering or the short circuits, as well as silk screen will be helpful to provide an information on a PCB which is very effective or very important when we are debugging the PCBs. Ensure clear labeling for your components and use proper masking coverage to prevent the short circuits. And few cost optimizing strategies like minimizing the number of PCB layers and selecting a standard components which are widely using and automated the assembly friendly design. So when even though there will be, we can design a same PCB based on the different factors, like let us say there is a very big form factor on a PCB. Form factor is nothing but an PCB dimension. If there is a very big form factor, then we can, if it is possible, if we can route all the things on a very top layer of a PCB without having a second layer, it is very highly recommended to use a single layer, because by naturally if you are increasing a number of layers, the PCB cost is also going to be increasing the similar manner. Let us say there is a cost of a PCB in a single layer is X price. By naturally double-sided or two-layer PCB will be kind of 1.8x or 1.5x based on your relation with the manufacturer. Let us say the same PCB, if you are designing in a 4-layer, by naturally the cost of a PCB will be going from X to 3x or X to 3.5x also. It is naturally happen in the market. So we have to design a PCB as low as with minimal number of layers, and to reduce the number of layers to lower production cost while maintaining the performance also. That is one of the key factor too. And selecting the standard components which are usually widely used in the day-to-day market and which are available in the market. so we can easily procure them and we can manufacture the things. And we should design a PCB in such a way by thinking the manufacturing process of a PCB, and such a way it will be so easy, and which will reduce the manpower cost, or which will decrease the timing of the production of a PCB. And few mechanical aspects of a PCB design like enclosures, mounting holes, and connectors. When we are talking about a mechanical enclosures, where the main intention of an PCB, where you will fix it in some enclosure. The enclosure might be an plastics, or might be in some metallic, or some aerodynamic related, some any other stuff. But fundamentally we will use the plastics or the conductive material or some other materials too. So we have to design the PCB in such a way of size and fit, ensuring a PCB fits within the enclosure with proper clearances as well as ventilations for allowing the air very freely without having any issues. Let us say few PCBs requires IP rating, which might not having ventilations. In such scenarios, we should have a proper thermal management internally to avoid the heating issues, and environmental protection using conformal coating or protective casing for the harsh environments. Like let us say when we are having a PCB, let us say you are designing a PCB for a traffic controlling system, then the PCB will be always located on in real time in the streets or in the center of the roads, which will be having effect of environmental effects like heat, rain, dust. When we are having these kind of scenarios or these kind of things, we have to design the hardware with proper placement of the components, as well as proper thermal management, as well as proper protection towards all these environment considerations also. That is also one of the main job of an PCB designer or an hardware engineer to keep in our mind. PCB designer or a hardware designer job is not only limited to see the things or to done the things as a PCB level. They should see the things as a product level, and they should ensure each and every aspect has been covered in the real time needs also. So and coming ahead, and few mounting holes and mechanical stability. So when we are designing a PCB, there will be a chance of placing a multiple PCBs in a single enclosure, as well as placing one PCB on top of another PCB. Let us say when we are designing a PCB for a car, in such kind of scenario, when we are placing a PCB inside a car, that will having a lot of vibrations. When we are traveling on a bus or when we are traveling on a car, if it is going by any speed breaker, if it is going to have sudden brakes, which will having a high vibrations, which will lead to destruction of the PCBs or damage of a PCB. So we should properly give the mechanical fixing holes, like placing mounting holes, using standoffs as well as spacers and vibration resistance to a proper PCBs also. Like strategically positioning the holes to support the stress and distribution and avoid PCB bendings, and preventing direct to contact with the enclosures to reduce the mechanical stress, as well as ensuring proper securing methods for the high vibration environments. There are different kind of techniques to address these issues, but these are the things we need to address by definitely as a PCB hardware engineer. Okay, while coming to an connectors placement, this is one of the kind of vital job role when we are designing and when we are in the phase of placement of your components, because connectors and interfacing designs need to be easily accessible by the human or easily accessed by other boards which are mating with these boards. Kind of connector placements ensuring easy accessibility and easy assembly to maintain the thing, and stress relief of the PCB, adding mechanical supporters to connector and to prevent the damage of the repeated uses. Because usually if there is a connector, usually we will plug and unplug the things. Like when, let us say the general use case is like our mobile, which is having one connector, nothing but our USB charger or as well as an earphone. These both are the connectors where we will use it in multiple times. So we should place the component and we should select the component, and we should also give the mechanical strength to that component, because it is going to be having multiple connections like plug and unplug in multiple times. and we have to test the stability of the component too. And when we are seeing regarding the cable routing on the PCBs, even though it is completely having tracks, on the few PCBs it is required to having a cable trace based on its requirement. So designing a proper cable management paths to neat and secure connections. When we are mating some few PCBs, let us say when we want to give 230 volts power supply to the PCB, which is converting from 230 to 5 volts, kind of an SMPS related circuit. Then we have to give the connectors in a proper way, as well as cable management to the PCB in proper way also. And case study of optimizing a PCB for industrial applications, like you can go through the image for understanding purpose, as well as the note which is having all the information like how we discussed as of now, like signal integrity improvements, EMC enhancements, thermal managements, DFM considerations, and mechanical strengths. Used control impedance traces and differential pairs for stability, high speed signals, like we discussed for in the initial slides, as well as the EMC enhancements, implemented properly grounding and shielding filter capacitor to minimize the interference, and thermal management like integrated copper pore, thermal via heat sink and dissipation of the heat, and DFM like the manufacturing constraints uses the standard trace widths, minimize the PCB layers, optimize component spacing for the cost effective, and coming to mechanical strength, designed secure mounting holes and added reinforcement for connectors to withstand industrial conditions and multiple plugins and plugouts. Those both picks will kind of self-explanatory, where you can go through them. If you found any difficulty or if you're having any doubts, we'll be discussing on the further or in the next session too. Okay, thank you. If anyone is having any doubt, please let me know.
Sir, you told that the thermal bias
Yes, ma'am.
we should not create unnecessary.
Yes, ma'am.
But that is a whole, sir. How does okay? I have created. Why it won't? Suppose if you that is only for management, no. The heat will get reduced, no. Hello, am I audible?
Yes, ma'am. Yes, ma'am. You are audible. You are audible.
Why? But you told that you should not put so many number of thermal bias. Okay.
We should not complete, means we should not place unnecessary wires until
Yes.
unless it is required. But for
Required.
thermal management, if it is required, we should recommend it to use. But if it is not required, if we have designed in such a great way, it is not required or it is not recommended to have multiple wires on the PCB.
Okay.
You understand?
Okay.
We
Yes,
should
sir.
have the trade-off in across both of them, and we
Okay.
should design in such a way.
Okay. Okay.
Okay.
Thank you, sir. I'm leaving, sir. Thank you. Thank you.
Okay, ma'am. Thank you. Sir, I have completed an assessment in EZD and tried to replicate in Altium Designer. I referred to some YouTube videos for guidance, but I noticed that some shortcut keyboard keys were not working properly. If possible, could you please provide a complete PCB design flow in Altium using simple circuit? It would be extremely helpful if you could explain it either after this session or through a YouTube video. For an example circuit, you could take something like triple FET. After completion of the basics of this Altium and the theoretical part, anyhow, we are going to design the easy EDF one schematic. I will be parallelly doing it in the Altium too, ma'am. When we are doing it in the Altium, if you are having any queries or if you are facing any struggles, we will be discussing them then and there, and we will be clearing those queries. Definitely, we will do it in the Altium also. Thank you, ma'am. If anyone is having any doubts, you can ask, or otherwise you can feel free to leave also, no problem. Okay, guys. See you tomorrow. Bye bye.